Morning Chem 1 students. We have one final gas law lab we wanted to show you. This one is similar to the last lab you did when you collected a gas over water. Remember how you bubbled carbon dioxide through a rubber hose into a tray of water with an inverted bottle filled with water? This is similar. We're collecting a gas over water today, but we're using a different apparatus. We're using something called a Eudiometer, which is really simply a glass tube that's open at one end. It's closed at the other end. But what makes it special is it's graduated. And it's very accurately marked, so you can get an accurate volume measurement of the gas collected.
Yeah, those collecting bottles in the last experiment weren't graduated. We had to use pour it into a graduated cylinder.
Yeah.
Where this will just directly give us
Right.
what the volume of gas collected is. Nice.
Yeah, I'm sure we had a fair amount of error last time trying to measure that volume.
You think so?
Yeah. Remember how we got over 100% yield for many groups? And yeah, this should be an improvement.
Yep.
So we're going to use that today. The reaction we're using is up on the board here. We're going to react solid magnesium with some hydrochloric acid, and that will end up generating the hydrogen gas that we'll collect. Okay?
So we have a stoichiometry lab today.
Yes.
We're going to know the mass of magnesium on the left.
We'll measure this mass,
Yeah.
and then we should be able to calculate the volume of H2 that should be made, and then we'll have an actual measurement from our experiment, and then we'll be able to compare and see what our percent error is between
Right.
actual yield and theoretical yield.
Mm-hmm.
And we should hit pretty close to 100%. Hopefully we don't go over. Okay, now there's going to be some data that we need to measure here before we start. So let's see if we can get some of that. So for instance, it'd be nice to know what room temperature is. And I don't know if I'm holding this still enough that you can focus on it, Mr. Moore. It looks like the temperature is just under 21 degrees. Let's call it 20.8 degrees Celsius.
Okay, I'm just going to turn it a little bit so
Okay.
we can see that. See there, you got 20 and 30. It's between 20 and 30. Very close to 21, but Mr. Helva gives us about 20.8.
About 20.8 degrees Celsius, room temperature.
Okay, we need the temperature.
Yep. We're going to use our barometer to measure the atmospheric pressure today. And so you remember reading the barometer. This scale on top is reading inches of mercury. We're at 29.83 inches of mercury. 29.83. And you recall, we're going to have to do a conversion to change this over into millimeters of mercury. So you probably remember this from the last lab. We've got 29.83 inches of mercury. We can convert it to millimeters by multiplying by 25.4.
Yep,
Okay.
we remember doing that.
Oh yeah. Now we're also collecting this gas over water, and so knowing the water vapor pressure at our temperature is going to be important.
Temperature is about 21 degrees.
About 21.
So yeah, we go to 21 degrees, gives us a vapor pressure of water about 19 millimeters.
Right. Okay. Let's see. What else do we need to know?
Well, you know, I didn't grab HCl. Did you?
I did.
Get HCl? Okay.
Yep. I got that. I think we need to know our magnesium mass.
I'm gonna come around you.
Okay, so, you know, the magnesium comes in a nice ribbon like this. We've broken off a small piece.
Now take a look at this balance. Reads to the 1,000th of a gram. Trying to make up its mind. My goodness.
Now it's sensitive enough that air currents, that's why this lid is here, air currents can cause it to jump around. Looks like it's happy now.
Yep.
It's like 0.036 grams of hydrogen.
Of magnesium.
Oh, magnesium, sorry.
Yep.
Okay. Now there is a little bit of trick to running this. What we're going to do is use concentrated hydrochloric acid, which we've poured some into this beaker. And concentrated HCl is more dense than water. So what we're going to do is pour that first into the eudiometer. And then we're going to carefully add water on top of that HCl. And because it's more dense, it will just sit down here at the bottom of the eudiometer.
Mm-hmm.
The magnesium will be up at the top. We'll show you that in a minute. And that way we keep our reactants separate until we're ready to go. And then we're going to invert the tube, and the HCl will sink down through the water column, and it'll gradually run into the magnesium and cause our reaction to start. You'll see this in a minute.
Mm-hmm.
Okay, so first thing I'm going to do is put on my safety goggles because it is concentrated HCl. All right, I'm going to pour that into our eudiometer. Okay, so there's our concentrated HCl. I'm just going to clamp it here for a moment. Okay, now I'm going to get some tap water. So we'll add to that. And I'm also going to rig up the magnesium. So we have a stopper here that has a hole through it. It's a one-hole stopper. There's a piece of copper wire that we stuck through there, and its job is simply to hold this piece of magnesium in place. We want it to remain at the bottom of the tube once we flip this thing over. So I'm trying to get this wedged in here so it won't move. To be a little careful because the magnesium ribbon can break easily. Of course, now I'm having trouble. Okay, I'm going to leave it that way. So the magnesium is pinned to the stopper pretty well. Okay. Now we're going to add the water to the eudiometer. So I'm going to tip it and try to just gradually pour the water down the side of the eudiometer so we can prevent the water and the HCl from mixing very much.
See, they mix a little bit in here. Kind of see a shimmering effect. But then down here, we've got very concentrated HCl that the water hasn't been able to make its way down to. Remember, the HCl is more dense than the water, so the water that Mr. Hevel's pouring in just sits on top of it. It's going to go all the way to the top. We don't want any air in this system.
I think I've done that. Okay, now I'm going to insert the stopper with the magnesium. Set this down here. This is the tricky part. It's not cooperating. Okay, so there we go. Magnesium's in place.
bit bubbly, but yeah, you can see the piece of magnesium is right up there next to the stopper.
And then our concentrated HCl, for the most part, still sitting on the bottom.
Yep. Right about there. I don't know if you could see that on the camera, but that's where our HCl meets the tap water. And you'll really be able to see it when Mr. Havel inverts the tube, turns it upside down, and the more dense HCl is going to work its way down the tube.
Are we ready for that? You think,
We're
Mr.
ready
Moore?
for that.
Okay.
Yeah.
So here we go. We're gonna.
The stopper at the top does have a hole in it, so he's going to have to plug it with his finger. He's doing that right now.
Okay, so we're gonna invert it into this beaker of water. Looks like I got one little air bubble in there.
Whoop. Well, we're going to pretend that didn't happen.
That's right.
And take a look inside of there. You can see kind of a churning of the liquids as that more dense HCl starts now to sink down into the water. See that happening? Water is really mixing well now with the HCl. And so that hydrochloric acid is working its way down the U diameter.
Looks like we're
gonna
starting to
Find
react.
its way down to the magnesium. Camera's focusing on the writing on the beaker, not on, there we go.
You want me to turn the beaker?
No, it's good, it's good. So it'll start slow, but it'll begin to bubble. You can see it's kind of picking up now. And as most of the HCl makes its way down, it'll really get bubbling.
Yeah, we're starting to collect some hydrogen now, for sure.
How are we doing up there?
A couple milliliters.
Oh yeah, so the water's being displaced as the hydrogen is made. You could just see the effect of all that hydrogen being generated and sent up to the top.
And if you look now, Mr. Moore, you can see the plume of fluid being forced
look
out
at
the
that
bottom.
down below.
That's the water that's being displaced out of the U diameter.
How's our chunk of magnesium doing? It's reacting away.
Yep.
The magnesium is going to be the limiting reactant. As soon as the magnesium is gone, the bubbling just stops. Sometimes the magnesium breaks free from the copper, and because there's so much bubbling going on, it actually will float up to the top. Oh, look at the size of those bubbles.
Yeah, big
So
bubbles
good.
coming
Yeah.
down.
And so, yeah, that level of the water in the U diameter is going down, down, down. And let's get zoomed in again.
I think we lost our piece of
Oh,
magnesium.
did we?
It
Oh,
either
here's
dissolved
the top.
or it's somewhere. I don't know where it went.
I don't see it. Still see some bubbles coming up.
Yeah, it must be a little piece trapped
There
still
must be
with a
some
copper
trapped.
wire.
The copper is not reactive with HCl, so it's a good holding material to use. Just that little tiny stream of bubbles coming up
Yep.
now from the
Yep.
probably just a small amount of magnesium. Okay, so where is our water level?
Now, one thing too that's different in this lab than the last one is we're going to equalize the pressure, hopefully, between the inside of the tube and out here. So we know the atmospheric pressure on the outside. If we can adjust the depth of the U diameter in the beaker so that the water level inside meets the water level on the outside of the tube, then we're guaranteed the pressure inside matches the pressure outside.
Mm-hmm.
Now, we didn't do that last time, as you recall, which probably threw us off a little bit.
Yeah, we had talked about the weight of the water in the collecting bottle, kind of pulling down and stretching
Right.
the gas out. We'll see if we can take.
So
now,
yeah, I think our reaction's done.
I do too. You know, we saw last time we zoomed in, we saw that steady stream of bubbling. That is done.
It's done.
Yeah.
Okay, so I'm going to unclamp this, and we're hoping we can adjust.
We turn that a little bit
Oh,
so
yeah, whatever you
we
need
can
to
see
do.
the.
Now, you know what? I'm going to
graduations
have
on
to
it.
add a little more water to the beaker. I can't
Oh, yeah,
quite
yeah,
get the eudiometer down there far enough. So hold on a second.
Mm-hmm.
I don't know if this is going to take too long with this little beaker.
It comes up.
Are we right on the
That's
bottom?
pretty close.
I don't know if I'm
Yeah,
right
no,
on the-
you're not even on the bottom either.
Okay, so now you'll have to help me, Mr. Moore. Am I?
Pick it up just a little bit,
Pick it up a
so that
little?
we can see the liquid level inside of
inside.
the. Yeah. Okay. Can you see that? Looks like the bottom of the meniscus, 39 is above 40, so the liquid level in the eudiometer is between 40 and 41, and it looks like it's just below the 40.3, which means it's greater than 40.3. Pick it up just a little bit.
Oop, I'm sorry.
All right, gang, what do you think? Should we just go with 40.3, 40.30?
Probably pretty good.
Yeah, 40.30. Write that down. That's our volume of hydrogen that we've collected, 40.30. Now, Mr. Hevel, did we do this procedure at standard temperature and pressure?
Well, no, we didn't.
No, we're certainly not at standard
Right.
temperature.
Yep, that's true. Our standard pressure, I'm sure, is
Yeah, because
Pressure
we
is
had
not standard.
the gas collected over water, we're not going to be, the hydrogen was not at standard pressure.
Right.
So I think that in our calculations, we are going to have to correct the volume that we collected to figure out what it would be at STP, so that we can compare it to the theoretical, which we assume is at STP.
Yep. We can do that.
We can do that.
Do everybody remember standard temperature and pressure? Standard temperature
Remind us, Mr. Hevel.
for gases, 273 Kelvin,
Mm-hmm.
and standard pressure, 760 millimeters of mercury. So again, you'll have to take the data that you have here for your volume, temperature, and pressure, and use the combined gas law and see what the volume of hydrogen would be if we were at STP conditions.
Right. All right, so let's see how we do for a percent yield. Were we close?